Hello, everybody. My name is Isaac Oram. I've been at Intel. I didn't put an intro in, but I've been at Intel since 1996, mostly in the biospace, and I'm mostly a UEFI person since the year 2000. I've been working on UEFI enabling, essentially. There have been a few other side projects, but I hear tell that we're almost done with Legacy Boot, but I'm not confident yet. Anyway, so a lot of time in Intel, a lot of time in the BIOS firmware space, mostly UEFI. And so the rather grandiose title today is the Open Platform Enabling Plans. And I'm going to get into, I guess, tying together some of the things we've seen in other sessions, Slim Boot, Min Platform, and our regular platform enabling. So the initial context that's driving much of this discussion is the Open Compute project and their plans for open systems firmware. So I'll talk about that a little bit. I'll talk about our open source solutions, what we call or are tentatively calling the minimum viable platform, but what we're going to put as an open platform out into tianocore.org and elsewhere, and then a little bit of wrap-up summary call to actions on our plans. The Open System Firmware project is a part of the Open Compute project, headed by Ron Minich and Devendra Good. It is a work stream that's focused on the firmware side of Open Compute. The big focus area currently feels like it's around the boot firmware, the system firmware, the BIOS, the UEFI firmware, the bootloader, whatever you want to call it. I use a lot of those terms interchangeably to me. The firmware that initializes the main CPU, the main memory, those kinds of pieces. That's what I'm talking about for the most part. I'll talk about some of the other IP firmwares, the other system controllers a little bit, but mostly this is a UEFI firmware or BIOS context. The other contextual thing is we're mostly looking at this Linux boot model as the basis for the open system firmware. So multiple firmware initialization or hardware initialization pieces above the line, once memory is initialized, OS loader, and an OS. And so we can see, whether it's the UEFI PEI doing hardware init or core boot ROM stage or U-boot SPL, it's going to have multiple hardware initialization options. And while this picture shows Linux boot, you can also think of a UEFI payload in this box. You can think of other Linux loaders. So there are multiple solutions at multiple stages in this stack. But this is the basic model that Open System Firmware Workstream is talking about. So the main driving thing for today's discussion, our plans, is around the Open Systems Firmware Ready logo discussion. And so this is essentially, the details will be worked out, but the objective is to have clear requirements for what matches, what is required to be Open Systems Firmware, to be Open Compute Project compatible firmware to get a logo. So the key points is they want to have solutions. We want to have solutions that are based on open source firmware, still with opaque binary blobs like FSP, but fewer of those, and fundamentally open firmware, open boot firmware. The target is 2021, so we've got a, not immediately, but a reasonably short time frame for the server community. And the key thing in here is it really is targeted at multiple solutions. So we spend a lot of time talking about x86 solutions, Intel solutions, UEFI firmware, and core boot, but it is really much broader than that. So those are the key points I would bring up about that. The key schedule timeline for the OSF proposal is was started in March of this year at the Open Compute Project Global Summit. We sketched out the basic timeline. Today we're talking, in the Open Compute Project Regional Summit in Amsterdam, we'll talk a little bit more details about the plans. In March of next year, we're looking to have the pieces in place such that open system firmware can be provided, but it's still not yet required. September of next year, we're looking to have systems coming from manufacturers that they may ship with a traditional firmware solution or a full firmware solution, but you'll be able to put open systems firmware on that. So that means the hardware vendors like Intel, we need to provide all the pieces, ODM and OEM need to build systems, but they won't be shipping yet. At that point, we're expecting to have systems start to show up, and we can finalize the requirements. That's the discussion, and that gives 6 months to meet the requirements before March of 2021, where it's possible to get a system that ships out of the factory with open systems firmware. So that's the basic context and schedule that's driving our Intel open deliverables for this, so that our customers and our ODMs can meet those timeframes. Is it sporting to take pictures of your own documents? I'm just kidding. Ron actually wrote the document link below, or started it at least.
I just like seeing an Intel logo on it.
Uh-oh. All right, so now we'll talk a little bit about the range of solutions that Intel has to feed the open source. And so as we look at this picture, on the left side, the open source pieces are going to show up. On the right source, the closed source proprietary pieces are going to show up. And the X scale, from my perspective, is basically as you go from left to right, you're going to get more flexibility and more complexity coming along with that. More features, but also a lot more system firmware. So it looks like a spectrum like this. We've got core boot as the most basic, slim bootloader right up there, the same level of this is just booting the just configuring the hardware and getting out of the way. Then you start to add UEFI payloads or things that build the system firmware. They get more complicated, that offer more driver models and pieces like that. The MIN platform is expected to come in a little more complicated than the payload. It's going to have SMM still. It's going to have security features, authenticated boot, and things that you won't find necessarily in the UEFI payload. And then we've got our traditional reference platform, our enabling platform, which is mostly closed source, but with some open source tianocore.org stuff. And then we have customer products built on the top of that. So this is our basic picture of the spectrum of open and closed solutions that Intel's enabling. And our primary vehicle for enabling these is the reference platforms for a given silicon chipset, given platform. So we're looking to have a spectrum of options available, and you've got to talk to us privately for specific roadmaps and what products support what. Not everything, not every platform, not every chipset will have all of these options available. For example, enabling made sure that I point out that we don't have direct core boot enabling from Intel for server silicon at this time. We do for many client products, but the silicon, we still don't have a plan in place to do direct core boot enabling. But we'll talk about the FSP and we'll talk about the MIM platform and how we can utilize those to enable core boot and other answers. So the thrust of our solutions are really to start taking steps to reduce complexity. At this point in the evolution of UEFI, we've got UEFI saturating much of the market. We have lots of UEFI solutions. We have lots and lots of features based on UEFI. And what we need to do is start to reduce the complexity, because there's a lot that goes with the current answer. So we're looking to reduce the complexity. MIM platform is a big part of that, making features more modular so they can plug into MIM platform or the full platform. That'll be another thrust of upcoming years. And then we have another focus to move both of these things into the more open space over time. So those are the two, I think, trends that we see in the firmware enabling for Intel. Is we've got to reduce the complexity and we've got to get more of it into the open. So in summarizing the different things that's coming from Intel, the slim bootloader, the MIM platform, and then the full reference platform, I think a couple key messages are that the MIM platform is the newest thing. It's to fit between the slim bootloader and the full reference platform that's closed. So the slim bootloader is open. It is statically linked together, a single image program. And the MIM platform is still UEFI, still EDK2, and PI architecture compliant, and has a dynamic driver model and all those pieces. But it's a lot less than the full BIOS. And then the full system firmware is still there, the full reference platform. All of these, we're looking to leverage the FSP to provide the one set of silicon support. One of the constraints for us as a company is we spend a lot of money on validating memory configuration and memory initialization code. And so it's very difficult for us to support multiple answers in that space. So all of these solutions are going to be based off of FSP. And the net result is we're looking to have three options. You can build a completely custom solution with the slim bootloader. You can build an EDK2 solution from the bottom up with the minimum features and add more into it, or you can take the full reference solution, full IBV solution, BIOS vendor solution, and reduce it down to your needs. So that's the spectrum of enabling that we're actively working towards. So talking a little bit more about the MIM platform, if you saw Michael's presentation earlier, he covered this, but the MIM platform approach was to break the boot into stages that are both reflective of how we bring up a new system as a team and as how a system bootstraps itself as it boots, as it goes through the boot process, bring up the hardware. So initially, stage one of the MIM platform is to get debug up and going. Get a serial port, get caches RAM, get a basic environment for doing memory initialization. Stage two gets us to memory functional. Stage three gets us to a UEFI shell with the basic just serial console, text input, text output. Stage four then adds basic ACPI tables and the pieces we need to boot an OS. Stage 5 turns on the authenticated boot and security features that we need to be ubiquitous as we go forward. We see that as table stakes for playing in the Silicon game anyway. Everyone has some sort of hardware root of trust, hardware boot solution that we have to deal with. And we want to enable that, whether it's BootGuard or whatever. And then advanced feature selection is where more things can plug in to build out the final system. So this is the basic MIM platform architecture. We've organized the code around these stages and organized the functionality around these stages and tried to make each of them useful without any of the others. So admittedly, the first stage of just getting a serial port up and running isn't the most interesting thing you can do with firmware. But if you just need to get through memory, stage 1 and stage 2 will get you through our system with the silicon initialized, the memory running, and then we could, at that point, jump to other things. We could jump to Linux boot from there. We could jump to Linux boot from later. We're envisioning those kinds of options being available to people, depending on how much or how little of the MIM platform they want to leverage. So the idea is that each of these stages is distinctly usable. And then there's another piece that we haven't really talked about because we don't have much of the infrastructure there, but the envisioned answer is there's also a stage 7 where after you've got all the features that come as packaged things, you go through optimization stage and you, if you saw the Fiano conversation, you remove all the Dixie drivers you don't care about, you remove all the PIMs you don't care about. Supposing you need something from USB, but you don't need the USB mass storage driver, we're going to have a USB feature that tries to plug in all of them and then just go through with the optimization and kill the USB mass storage device because you don't need that one. So that's the basic MIM platform model that we're working towards. And then, so when we look at that and then the full reference platform will eventually be the MIM platform with all the rest of the UEFI stuff that we use for silicon validation, for customer enabling, setup browsers for doing configuration and those kinds of built-in things. Those all show up as advanced features or as proprietary features on top of this basic, this open baseline. Talking about the relationships of these things and from another perspective, on the bottom we have the common building blocks, and this is where I'm going to start evolving from the MIM platform, which is the IA system firmware, to the full integrated firmware image, or the full platform, which has the ME firmware, ACM TXT firmware, if you're familiar with Intel Trusted Execution Technology, those kinds of pieces. So in the base level, we have common building blocks, a MIM platform and a motherboard port of that. We've got the Intel FSP binary for silicon initialization. We've got microcode binaries for the CPU. We've got the Intel server platform services binary, also known as the ME binaries. So we've got all these different pieces, and we're envisioning OpenBMC as the BMC solution for open compute. We've got these basic pieces that are common to all of the answers. On top of that, or if you add a few more pieces that make it a usable system, then you get a minimum viable platform. And so the key attributes of that is it's the set of building blocks with minimum functionality, and then open source MIM platform code and opaque binary blobs for the rest of the pieces initially. And then the key timing for the minimum viable platform is we can start open sourcing things after the product's launch. So we can't do open source development at this time, we're limited, but once we launch a new processor, a new platform, we're looking to flip the minimum platform port open and the binary FSPs and these other pieces open. So they'll be freely available, downloadable, and redistributable. On top of that, we've got the full reference platform. This will be closed. This is the platform and development and validation in the vehicle that we use to build all these things. It has lots of features, and it's the traditional ecosystem enabling tool. So that's the basic stack of how the full platform, MIM platform, and the building blocks work together. So in the Venn diagram picture, the key thing I want to stress here is the FSP is the same throughout all of these. The MIM platform is looking to be the same throughout all of these. The binary pieces are looking, we're not having multiple flavors of these things. It is consistently adding things on. They're not 100% supersets, but for the most part, 95% plus of the source code will be shared and reused, and that's the model for these things. So a couple notes on that. The minimum viable platform is probably not an actual deliverable. It's probably going to be posted a little more ad hoc than that, and likely won't show up on platform roadmaps when you're talking to Intel or published material. You've got to look at the actual platform information and extrapolate that, okay, at this platform launch, these pieces are going to come open. The minimum viable platformer is an initial open source target. We don't believe that it's going to be a fully featured solution for quite some time. So we're expected to require proprietary code and or additional binaries to have a really useful system. The minimum functionality is not your minimum PC functionality or your minimum enterprise server functionality, or even necessarily your minimal cloud server at this time, or hyperscale server. So we're missing things in manageability, updatability, those kinds of pieces. Those we're looking to have built on the communities as we get things out into the open. And then the other note, to facilitate the spread of this, we're looking to control the rate of change in the FSP specification. We feel like with the FSP 2.1 specification, we've started to have a little fragmentation in the ecosystem. We've got 1.0 and 1.1 and 2.0 and 2.1 versions of the FSP. So we're really going to try to stabilize and get all the binaries to the same level before we embark on the next round of change. So our basic direction to keep that stable for a while so we can get it into use in core boot, U-boot, and all of our answers. And so the last note on that I skipped over is, for the near future, if we do need additional functionality for servers that's proprietary, we're looking to use the UEFI modularity to deliver that, so we can publish Dixie drivers and PIMs. And it's not a great answer, but you can do something like core boot plus FSP plus a UEFI payload plus a proprietary binary blob of UEFI stuff. And we can build those answers if we need those until we reach a more proper open system firmware fully functional answer. All right, so talking about our part of this. So we've got the context, we've got the open systems firmware timeline, and we've got this basic target of a minimum viable platform. Where we are right now is we've got some of the common building blocks posted onto various places. So we've got the microcode, we've got Intel TXT binaries, and we've got Intel FSP for a variety of platforms. We need to start getting those out there for more server platforms, so that'll be the next focus. But we've got examples and the licensing, and we've been working through that. We're working currently on the SPS licensing and tools that we need for the MIM platform to get those going. And so right now it is not one thing, it is a mix of different versions and different pieces, and it's mostly just showing, demonstrating that we've got this piece open, redistributable and available. We've got the next one coming. So it's a mix of MIM platform proof of concepts and ports and things like that. So we're not really expecting until the next platform generation for servers to have a fully integrated, fully usable proof of concept and baseline to start from. So the next steps, we are developing that proof of concept for the next generation of Xeon SP servers, and we're looking to we're developing the MIM platform ports for our reference platform. So the basic model there is we can do a reference platform, and then derivative board designs can leverage that to quickly produce their own open board ports. After products start launching, so this next time frame is the next 6 months to the next March milestone for OCP, Open Systems Firmware. So at that point, at the next milestone, we look to have the committed schedule for the Intel platform deliverables. So if you talk to us right now, we don't have the schedules, but we're working on them. By March, we're looking to have all the schedules for our next generation of Xeon SP nailed down so people can build their products based off of them and their plans. And then at the future time when OSF is required, we feel like we're on track. We feel like we're making progress towards the commercially available Intel platforms having and able to meet the OSF logo based on our current trends. So that's really the key message today. We're doing MIM platforms. We're doing FSPs for the future Xeon SP products. We don't have a lot of detail. We don't have timelines yet. That's much more under the private disclosure discussions. We can talk about those things. But as a general direction, we really want to say that we are working towards this milestone and enabling this for our partners in our development ecosystem. All right, so a few notes on the deliverables. Again, product launch is the key dependency for us. We really can't push things into the open or work on them publicly until those silicon products launch. We have some concerns and risks about FSP API mode for multi-socket functionality. We've got a lot of desktop and a lot of client systems and single socket SoC-based server systems that are using the FSP. We believe that we'll get the FSP functional for multi-socket systems without any issues, but there is still a little asterisk. It hasn't been done yet. It's not mature, so all statements are forward-looking on the schedule because we've been burned before. It looks really easy until you start debugging some of those multi-socket issues. But in general, we believe we're moving forward well. We've got good initial data and those kinds of things. And then the other key limitation is we don't currently have a plan to support system management mode functionality. So this shows up in a variety of manageability and update features in the server space today. In the client space, updates are largely driven through capsule updates or some other reboot-based mechanism. In the server space, it's still typical traditional BIOS update where you run a program that goes into SMM and reprovisions the flash image. And so there's a fair amount of work to do to get away from that model into an SMM-free flow for things. So those are some of the limitations that I want to keep in people's minds, that we've got still a lot of SMM dependencies today in the firmware, in the server space. And we still got some risks associated with the multi-socket functionality. But basically, that's it. The OSF Ready logo program is expected to happen, is expected to drive open systems firmware into the server space and drive solutions, and we believe we can support that. We are using the FSP as our primary silicon enabling vehicle for these efforts and for a range, a spectrum of firmware solutions. And we're producing MIM platforms as the open enabling version of EDK2. So the call to action, learn more about the OSF work. There's the Open Systems Firmware website, and there's a variety of documents going with it. And then the MIM platform stuff is out there, largely instantiated on the client side right now, but with the next generation of products, server versions will go up on tianocore.org. The specification is there. It's very much a draft specification. We're looking to evolve it to meet everyone's needs. We published what we think we need, what we know we need to align with our validation efforts and our silicon development. And from there, I think we can take it in a lot of directions. So engagement on the MIM platform specification is definitely welcome. And with that, I'd like to open it up to Q&A.
Late last year, there was a lot of press around some thoughts that Intel might open source the FSP. Is that, A, was that ever planned, and B, may that happen in the future?
It depends on what you mean by planned, and so I don't feel like I can answer that in any useful official way. But yes, we are still looking at that. We don't have concrete plans at this time. So there's a lot of things that have to go. As you look at Ron's 20-year history, in the intro, Intel has moved a couple different ways over history, and so I feel like we've got a lot of momentum moving towards more open specs and more open things, but there's still a lot of work to do. So it's not something that we would talk about a time frame for yet. by any means.
Could you please shed some light? What are the issues getting FSP to work on multi-socket configuration?
It's a risk statement. There's a greater than 25% chance that we'll hit some hard issues in making it useful. So when we look at the memory initialization in the server code, it is multi-socket today, and it's a very specialized magic hardware, low performance buses, and so we haven't worked that out. We're not worried about the bootloaders. EDK2 and Core Boot both have long histories in HPC and server and enterprise and things. It's, is there some limitation to the FSP spec? Is there some limitation to the implementation? We haven't. So it's purely a risk management statement to say we need to be a little cautious. If you're betting your business on building something off of an FSP that's going to show up in 9 months, that's probably a high risk bet, since we haven't done it yet. That's the main message there. We haven't hit any issues. We've got FSPs that are booting multi-socket in their early functionality, and so we haven't hit anything yet. But our multi-socket initialization and our memory initialization are complicated endeavors.
So you mentioned redistributable components for Intel TXT. What does it mean? So do you mean BIOS ACM or
Yes.
ACM?
So there are the question. What do I mean by Intel TXT binaries? So the BIOS ACM binaries that hook into the fit table and do the initial boot guard authentication, we can make those available to do measurement. I mean, they have a different functionality, but yes.
So what would be the license? Would the license be like microcode and FSP?
Yes.
That's
yes.
great. That's very good news.
So that happened a month or two ago, maybe longer than that, and we're working on the ME currently to get that.
What platforms will be covered with that?
So the first one we posted is Cascade Lake, and it will be going forward. So we don't expect to have all the pieces for Cascade Lake. We expect to have all the pieces for the next generation.
Okay, so this will be only for newer platforms, not anything else. Okay, thank you.
We have a difficulty going backwards at this point in time. So.
What was your timetable on actually aligning all of your offerings to FSP 2.1?
Oh, that's a good question. I should have seen that. I don't have a timetable. So we're pausing new spec development and letting everything catch up. So the long pulls tend to be the server products, but the embedded teams may also have some projects that are still 2.0 and things like that. I think we're catching up. We've got the initial 2.1s out there for client, but I don't have a hard time.
3 years?
Oh, it'll be less than that. I'm pretty sure.
Okay, because it has some severe limitations.
Okay. Yep.
Tell me if this is off topic, but the FSPs take a long time to init memory, and you keep saying how complicated it is. Is that going to get more and more complicated and slow forever, or is it going to settle down? And is it possible to have a memory in it that's targeted, perhaps not quite so, getting the maximum possible performance out of a system, just have a slightly crappy memory in it?
That is an excellent question. That's what we were talking about at lunch. There are definitely segments that would make that useful, but I am not aware of any good enough memory init things in the server space. Our driver is definitely performance and bandwidth and throughput, and performance and bandwidth and throughput. And we're trying to make boot speed, and we've got lots of great feedback that, systems need to boot in less than minutes. But the driver does appear to be performance. And so it's a balance for us. It's a struggle for us. So I don't know any concrete plans. I'm fairly pessimistic that we can really make things simpler. I think, we can make efforts like MIM platform, but if I look forward 5 or 10 years, I see Moore's law continuing. I see 10x more firmware being more likely than half as much firmware. And I don't know how to really get off that treadmill. I see a lot of positive effort, and I think we do things to simplify it along the way. But ultimately, I'm not aware of anything that's going to be a magic bullet for that. So we are adding new memory technologies. The non-volatile memories continue to increase the complexity and what's going on in system memory topologies. So I don't have any particularly good news on that front, but I wouldn't be involved. So where Intel is doing that, I'm not the right person. I'm more the product firmware deployment side, not the cutting edge memory development side. So take my answer with a grain of salt.
I just remember that you expressed frustration at a future where there could be some platforms on FSP1 and 1.1 and 2.0 and 2.1. Did that mean that maybe there would be a desire to bring everything up to 2.1 eventually?
Yeah, so we'd like to let all of our things catch up, but it's a general just simplicity and simplifying core boot and other bootloaders, supporting the multiple versions. I mean, the specs are pretty reasonably compatible and related. Like the old stuff didn't get thrown away. So I think it's completely reasonable for a bootloader to support multiple generations of the FSP. But at the same time, we don't want to always have here's the next spec coming, fragmented ecosystem. We would like to really get our roadmap complete rather than have more bifurcations. But I mean, we're open. I think it's a general directional statement based on our history with UEFI and how fragmented we let things get in that experience. So.
But I think that question is about the trailing window. I mean, you're not taking old platforms and moving them to 2.1. You're looking at your products and getting them all up to 2.1. Correct? Is your statement? Yes.
We keep on hearing that memory training is very complicated, and maybe it is, but there are systems which may not require all the complexity to train the memory, like system with soldered down memory. Is there any plan to maybe open how training is supposed to work in this configuration, so some customers might be able to implement their own training or like reduced version of training or something like that, so that we wouldn't have to depend on this thing which is supposed to cover thousands of different configurations of chips?
So I'm not aware of any plans at this time. So we're working it as a general direction to be more open with even the silicon stuff and the document. One of the things that came out of this conference is thinking about the documentation as well as an answer. We don't necessarily, we've been thinking very strongly reference code for the last decade or two at Intel, and moving from purely spec-based, NDA spec-based enabling to here is functional code. And that's been the last 10 years or so. And I think it's an interesting thing to bring up that there is the mix in the open world where we can just make the documents available, and maybe we need to do more of that. But right now, my experience is we've been very focused on reference implementations and binaries that people can use, and not so much publishing specs. So I'm not aware of any plans. I think it's an interesting direction. I think there's opportunity there, but we don't have plans to my knowledge at this point.
Let me turn the earlier question around. Other than asking at conferences like this, what's happening? What can we as Intel users do to help push Intel into this direction of more open documentation, more low-level init, such that as he mentioned, we may not necessarily have the full set of requirements, but we want to get a minimal firmware product shipping. Where at Intel is the right pressure point to push in that direction?
I'm going to give a pretty generic answer to that one. So there's a couple places, you can work with us on the open Tiano Core and other places like that, and you can work with us in a collaborative way on the pre-launch development. And I think that's a thing that we need to work on going forward is this constraint of being open post-launch is a real problem if we can't collaborate effectively pre-launch. So how do we create some sort of quasi pre-launch collaboration where people can have input? Because it does us no good if we open the silicon code and then tell you, yeah, none of your changes are acceptable or valid. We're not, there is no upstream path. So that's a hard problem that we're only in the early stages of thinking about. We've got a step one that's get the information public, a step two that's figure out how to use it in some sort of effective way. So nothing concrete there, but the feedback is welcome. And I think working with us collaboratively in some way of committing things back to us, in a one-on-one, point-to-point thing might be the first steps. But yeah, that's the essential thing we're going to do. If we are ever to get to some sort of open thing, we have to be better at taking feedback in. And right now, just simple schedules don't line up and things like that. So it's very difficult.
Yeah, one thing regarding SMM, you said we want to thin down SMM. That's one thing, but you said there are no plans to support SMM and FSP. Is it in the long run? Is it a time thing? Or?
Right now, it's time, effort, and priority thing. We don't have the people working on a different answer. We don't have the time to intercept the different answers. So we're working on the PRM. So we've seen Sarathi Jayakumar talk about that at the OCP Global Summit, and a little bit mentioned it here. But yeah, so we're working to reduce the SMM, and I think there's a lot of consensus that it would be nice to have systems without SMM at all, or severely limited and constrained SMM. I think. Well, I won't go.
Yeah.
So we're looking to reduce the SMM, and we're looking to provide some alternative answers, and that's another area where there is probably a good opportunity to move things from the BIOS space to the OS space. So Linux boot is one big place where we can move functionality out of the BIOS system firmware into a more OS level, and then runtime. I mean, from the very beginning, everyone has hated UEFI runtime. Like, we don't want BIOS code running at runtime. We want OSs running at runtime. But for whatever reason, some of these capabilities and features have utility that keeps them around. So that's the fight. It's reduce as much as we can the runtime footprint of firmware. It's a security challenge. Anywhere you can interface directly with the BIOS, anywhere you can start changing system configuration and functionality. So we'd like to reduce that. And so it's just for the next generation of platforms, I think we have the feature set we have in the SMM space. But we're working PRM, we're working on offloading things to other controllers, and we'd like to see Linux boot take more of those pieces, and OS level drivers take more of those pieces.
Okay. And the other thing is, FSP, does it have mandatory pieces that are uniform across all the customers, or will there be configuration options that people can further strip them down to their platform needs?
Yeah, so I think we definitely like to go in the latter direction of having the ability to strip things down. I think Fiano obviously demonstrates something that was always intended there, that you could remove the tools. There's a tool in pianocore.org, FFmpty, that's the same thing, pull out modules and things. So I'd like to use that modularity rather than a build time feature flag modularity. And I know there's some size penalties to that, but it's an incremental step where we can align on things, and we can have we can do cryptographic hashes of FSPs and have known answers and things like that if we have some consistency to how we do that versus builds. So we are also looking at bringing back reproducible builds, if you're familiar with that. But two different systems, two different build targets should be able to build the same binary. We'd very much like to get that capability back. We had it, and at some point we just stopped testing for it and lost it. So that's
all
part
right.
of it.
I'm afraid we have to cut it here because we have to make it. Thank you very much again. Round of applause.
Thank you, everyone.